Welcome back to the Deep Dive. Today we're jumping into something moving incredibly fast, AI agents. It's specifically a new standard helping manage them, the Model Context Protocol. We're basing this deep dive on a pretty thorough analysis from a BCG AI agent report. It gives a really good snapshot of what's happening now and maybe more importantly, what the near future could look like for these more autonomous AI systems and, how businesses are actually trying to handle them. So our mission today, unpack this evolution. We'll look at how these agents are getting genuinely capable, where they're already adding real value, the big challenges around reliability, making them trustworthy for real work, and how this Model Context Protocol, or MCP, fits in. Is it a key piece for integration, control, maybe security? Okay, let's dig into this report.
Absolutely. And the report really kicks off by highlighting this fundamental shift. We're moving beyond what you might call agentic if statements AI, following pretty fixed scripts, basically.
Right, like simple workflows.
Exactly, towards systems designed to be genuinely autonomous.
So how did we get here? From those simple scripts to, autonomy. What steps does the report map out?
Yeah, it lays out a clear progression. Started with the original LLMs, basically just sophisticated token predictors, right?
Autocomplete on steroids.
Pretty much. Then came instruction fine-tuning. That gave us the chatbots we're all pretty familiar with now. The next step was kind of bolting if statements onto these. The report calls them agentic workflows. So trained for specific tool use, structured output, but still within a, defined process.
Okay, still fairly guided.
Right. The big leap, according to the report, is to autonomous agents. These are trained differently with this core loop: observe, plan, act. They're meant to reason. The report mentions improvements shown by things like test time compute, TTC, on complex reasoning tasks. They can use tools more dynamically, manage resources, pursue a goal more independently. And then there's this further stage, though the report says it's still very early days, multi-agent systems. The idea of agents actually talking to each other, sharing context, aligning on goals, coordinating plans.
It really does feel like this is all happening incredibly quickly.
Oh, it is. The report really emphasizes how fast the techniques, the frameworks, the infrastructure, it's all maturing. You see the big players integrating agent capabilities, open source frameworks like LangChain, Pydantic, others evolving super fast.
Lots of names popping up.
Yeah. Anthropic, Hugging Face, OpenAI with assistants and Copilot, Bedrock agents from Amazon, Lindy, Dust.tt, Intercom.
Yeah.
It's a busy space. And it's not just the frameworks, right? The underlying models are getting better too. More modalities, voice, image, video. Reasoning is improving, dramatically. That report stat about an 81% performance jump on AIR-C-AGI using test time compute methods in just 6 months. That's huge.
81% in 6 months is definitely fast.
And then there's the open innovation aspect, performance going up, costs dropping. The report suggests something like 8 to 10 open source models are now matching or even beating GPT-4 performance. And that's leading to maybe a tenfold cost reduction for that level of capability.
So better models, better tools. That's driving the shift you mentioned, away from just chaining prompts together in a fixed sequence.
Right, prompt chaining where you script the LLM calls sequentially.
Towards these more self-directed agents, they can reason, act, learn from feedback, react to things. It's like the difference between following a recipe and being a chef who can improvise.
That's a great analogy. Prompt chaining gives you consistency. Autonomous agents offer flexibility. They can use their, general intelligence for things you didn't explicitly plan for. And the report does look ahead to this multi-agent future. Not just agents working solo, but collaborating in networks. And crucially, collaborating with humans. They give this example of end-to-end supply chain management.
So humans and agents working together in the same process.
Exactly. Coordinating information, making decisions together. The report cautions against thinking of them just as microservices, Yeah. It stresses focusing on the network effects, the collaboration potential.
Okay, that makes sense. Which brings us to the big question. Is this mostly hype and potential, or are these agents actually delivering results now? Where's the product market fit today? Here's where it gets really interesting.
Oh, definitely seeing results. Coding agents are probably the clearest example of hitting product market fit first. The report mentions these vibe coding companies, Cursor, Replit, Bolt, others. They're seeing real user growth, real revenue, helping developers write, debug, refactor code.
But taking that, helping with a code snippet to something fully baked into an enterprise development pipeline, that seems like a big jump. What does the report say about bridging that gap?
It acknowledges it's a jump. It says moving to production requires maturity, the code needs to be modular, maintainable, the agents have to integrate smoothly with existing tools, version control, CI/CD.
And meet all the enterprise security and compliance requirements, presumably.
Exactly. Authentication, data protection, auditing, all that has to be solid.
Okay, coding makes sense as an early adopter. What about beyond developers? Where else is the value showing up?
The report gives some pretty concrete examples. Bloomberg, for instance, using compliance agents, checking facts, spotting risks in communications, reportedly cutting decision time by 30 to 50%.
Wow, that's substantial.
Yeah. And Booking.com, Jane Street, using coding agents to free up developer time, cut cycle times by over 30%. Then there's Brightwave, using research agents to process huge volumes of legal or financial text, pull out takeaways, cross-reference data, things humans couldn't do at that scale that quickly. BCG even mentions their own internal use, deploying over 300 GenAI agents across more than 100 client projects. The report gives illustrative numbers, potential for up to 90% cost reduction, 50-75% faster execution, maybe 30-40% of productivity uplift, though they do stress those metrics vary a lot.
Right, illustrative, but still points to significant potential.
And looking forward, the report suggests a mix. Fully autonomous agents for complex tasks, but only as reasoning gets better. Assistive agents, blending AI and human judgment, especially in high-risk areas. Rule-based agents as guardrails, and adaptive agents that learn from feedback.
Those numbers, even illustrative ones, are impressive. But it really hammers home the critical issue: reliability. Can we actually trust these agents to be effective, especially for complex or high-stakes tasks? So can they be reliable and effective?
That is the core question, isn't it? And the report makes clear that evaluating this is, well, it's still evolving, benchmarks are shifting. It's not just about simple tests anymore. It's about measuring how well they use tools, how they handle complex end-to-end tasks over time in messy, real-world-like environments.
Like seeing if they can actually complete a job, not just answer a question correctly.
Exactly. We saw things like the Columbia Journalism Review finding issues with AI search citations.
Yeah.
So new tests are pushing edge cases. What if a tool is missing? How does it handle ambiguous requests? There's more focus on multi-turn tasks, managing context, getting steps in the right order, adapting if the goal changes, like, say, automating parts of ML model training. The report mentions RE-Bench too, specifically looking at frontier AI R&D capabilities compared to humans.
The report had this really interesting metric on the length of task automation. Could you expand on that a bit?
Yes, that was quite striking. What the report found is that current state-of-the-art models can, in theory, do some individual steps or tasks that might take a human expert hours.
Okay.
However, when you look at completing a sequence of actions reliably end-to-end, they're currently only reliable for tasks that take maybe a few minutes.
Only a few minutes reliably. That feels quite limited, considering the hype around automation.
It does seem that way initially, but the key thing the report points out is the trend. Apparently, the length of task that these systems can handle with about 50% reliability.
Well, that length has been roughly doubling every 7 months.
For the last 6 years or so.
Doubling every 7 months.
Yeah, exponential growth. Here's where it gets really interesting.
Okay.
If you extrapolate that trend, and it's a big if, of course, but if it continues, the report suggests that by the end of this decade, AI systems could potentially be capable of autonomously carrying out projects that would take a human maybe weeks or even a month.
Month-long autonomous projects by, say, 2030. That definitely puts the few minutes today into a different context. So, to get from minutes to potentially months, what are the main roadblocks right now? What's holding them back? The report mentioned those 6 dimensions for tracking performance.
Right. They have 6 dimensions for 2025 tracking. Reasoning and planning, task autonomy and execution, memory and knowledge, reliability and safety, integration and interoperability, and social understanding. But if we boil down the current key limitations highlighted...
What were the big ones today?
Okay, first, reasoning and planning. They still really struggle with complex, multi-step logic, keeping track of dependencies. They can get lost, make things up, hallucinate, especially over longer sequences. Second, task autonomy and execution in the real world. Simulating tool use is one thing. Robustly integrating with actual messy external systems, handling errors gracefully, adapting when things don't go as expected, that's still really hard.
So brittle in the face of real-world chaos.
Kind of, yeah. Third, memory and knowledge. Limited context windows are still a thing. Accessing and using external knowledge, like from databases, effectively and consistently, still a challenge. They can forget things or not pull up the right info. And fourth, integration and safety. Just connecting securely to all the different systems inside a company is complex. Data silos, different formats, and then giving agents the power to act through tools. That opens up huge security risks if it's not managed perfectly.
Okay, so reasoning, real-world action, memory, and then secure integration. Those are the biggies, keeping them stuck on shorter tasks for now.
That sums it up pretty well. Brilliant on maybe isolated steps, but stringing together a long, reliable, secure sequence using real tools in a real enterprise environment. That's where the current limits really show.
Which I guess leads us directly to the Model Context Protocol, MCP. How does that try to tackle some of those specific issues, especially around integration and accessing tools and data?
That's exactly what it's aimed at. The report flags MCP as a really significant development. It's open source, came out of Anthropic in November 2024, and then saw an incredibly fast uptick. By April 2025, you had OpenAI, Microsoft, Google, Amazon, all announcing support or integration.
That is fast adoption. So what does it actually do?
Fundamentally, MCP standardizes how an AI model acting as an agent gets access to external stuff. Resources and tools.
Okay, define resources and tools in this context.
Sure. So resources could be data or content like files, database records, maybe vector DB results. Tools are actions the agent can take things that modify state or interact with systems, like sending an email via an API, updating a Salesforce record, running a query. MCP servers are set up to expose these resources and tools in a standard way. The agent acting as an MCP client talks to the LLM using this protocol to figure out what it needs, but the key is the interaction goes through the MCP server. It's like a gatekeeper wrapping access to the actual underlying system, say Salesforce or a database.
So the LLM doesn't talk directly to Salesforce.
Exactly. It talks via the MCP server, which controls and standardizes that access. This is meant to give the user or the enterprise much better control over what the LLM can actually see and do.
Like that Salesforce example they used. User wants an update.
Precisely. User asks us update an opportunity. The agent's LLM figures out, okay, I need Salesforce. It uses MCP to ask the Salesforce MCP server, what tools do you have? Gets back something like update opportunity details. The LLM decides, yep, that's the one, figures out the parameters, sends the request back to the MCP server. The MCP server then validates it, maybe checks permissions, and then securely calls the actual Salesforce API. The LLM itself never touches the real API.
Got it. A standardized, controlled middle layer. So how does that map back to those limitations we talked about, reasoning, execution, memory integration?
Well, it directly targets some of them. By giving standard access to tools and data, it helps with task autonomy and execution in real systems. Makes it easier for the agent to actually do things. It helps memory and knowledge by providing standard ways to access databases, knowledge bases, vector stores. The agent doesn't have to hold everything in its context window. It can query for information through MCP when needed, and it's explicitly designed for integration and interoperability. A common language for tools and resources helps break down those silos, at least from the agent's perspective.
Okay, so it tackles execution, memory access, and integration. What about reasoning or safety?
Yeah, the report notes that core reasoning ability, reliability in terms of avoiding hallucinations, safety guards, even social understanding, those are still primarily properties of the model itself. MCP doesn't magically fix a model that hallucinates, but it enables the agent to apply its capabilities more effectively and safely in the real world by structuring how it interacts with tools and data.
That cross-industry adoption in just months. I wanted to catch on so fast. What did the report say were the drivers?
A few key things mentioned. It was genuinely AI native, designed for this problem. Being open source was huge for broad buy-in. Having Anthropic launch it with a full stack and a clear, fast roadmap gave it real momentum.
And maybe some familiarity.
Right. The report mentions it builds on ideas similar to the Language Server Protocol, LSP, which developers already know from coding tools. That probably helped adoption. They even included charts showing MCP adoption outpacing earlier frameworks like Crew AI or LangGraph quite significantly.
So in terms of enterprise architecture, where does MCP fit? Is it like a new middleware layer?
The report uses the analogy of a new data mesh, but specifically for agents. Instead of every single agent needing its own custom integration to Salesforce or your internal database or whatever.
They all talk to the Salesforce MCP server.
Exactly. You build the MCP server for Salesforce once. Then multiple agents can use it via the standard protocol. It deduplicates that integration effort, makes it faster to try out new agents, and easier to upgrade the underlying system later because the MCP layer provides abstraction.
But the value depends on good agents using it right.
Absolutely. The report emphasizes that. MCP's value hinges on the agents consuming it and the overall ecosystem adoption. It's an enabler, not the whole solution.
Okay, let's talk security again. Standardized access is great, but if agents can now easily call APIs and update databases, that sounds potentially terrifying if not done right. What specific risks does the report highlight with this tool access?
This is absolutely critical, and the report is emphatic. Security cannot be bolted on later. It lists several major risks. One is just malicious or compromised tools. If an agent uses a tool that's been tampered with, that tool could potentially grab credentials or data using the agent's permissions.
So the tools themselves need to be vetted.
Definitely. Then there's tool poisoning. An attacker could potentially inject bad instructions into the description of a tool that the agent reads, tricking the agent into doing something harmful. There's also this user view mismatch issue, linked to prompt injection. The user might see a simple summary like updating Salesforce, but the actual underlying request to the model could contain hidden instructions exploiting the tool's full capabilities, making the agent do something unintended.
Sneaky.
Very. The report also flags risks like server-side logic changes, someone altering how a tool works after it's been approved, and a compromised MCP server itself potentially breaking security boundaries between systems.
So while MCP standardizes the road, you need really robust security at every junction and destination.
Exactly. The report insists security must be foundational. Treat tool logic, treat the MCP servers themselves as potentially untrusted, enforce strong authentication like oath and a role-based access control on every single call through an MCP server, not just once at the start.
Every single call.
Every call. Plus, pin tool versions so they can't be silently updated, isolate trust domains, log the agent's reasoning trace, not just the final action, verify code implementations. These are crucial. And the report stresses these risks aren't just about MCP, they apply to any system giving AI agents tool access.
Makes sense. It's a general agent security problem. MCP just provides a specific context for it.
Precisely. And it's worth a quick mention, the protocol space is still moving. The report touches on things like Google's A2A, agent-to-agent protocol. That's more about how agents coordinate with each other, share context, plan together.
So MCP is about accessing resources.
Okay.
A2A is about agents talking to agents?
Roughly, yeah. MCP helps with resource tool access and discovery via things called agent cards like directories. A2A is about the conversation between agents. The report suggests they'll likely work together, but expects some fragmentation here too for a while.
Okay, pulling it all together then. Agents, MCP for resource access, maybe A2A for coordination. How does a company manage all this? The report mentioned agent orchestration platforms.
Right. Think of orchestration platforms, Azure AI Foundry, Google Vertex agents, Amazon Bedrock agents are examples as the control plane. They manage the agent lifecycle, deploying them, monitoring performance, coordinating their work. And the MCP registry, mentioned in the report, acts like a central directory service within the organization, cataloging all the available MCP servers.
So the orchestration platform is the manager, and the MCP registry is the phone book for resources.
Good analogy. The report suggests this combination, the orchestration platform plus MCP, will likely become the beating heart of a modern AI company's architecture.
And the key takeaways for building enterprise agents with MCP, according to the report.
It boils down to a few principles. Use evaluation metrics to drive development. Plan your MCP server strategically to unlock key data silos. Build or adopt an orchestration platform and registry. Get legal, security, privacy involved early. Use SDKs and frameworks to speed things up. Design your tools to be precise. The report suggests aiming for under 100 options per tool call if possible. Rigorously evaluate the outputs. Keep MCP servers modular, one per system, ideally. Secure every interaction, probably using OAuth, and focus on lean servers with dynamic discovery.
Wow. Okay, that was quite a journey. We've gone from the basic evolution beyond simple chatbots to seeing real-world value despite current limits, grasping that pretty staggering trend about automating longer tasks, and now diving deep into how protocols like MCP are stepping in to standardize that really complex, critical piece, how agents access tools and data securely in the enterprise.
Yeah, and MCP isn't, a magic wand for everything. It won't fix a model's core reasoning flaws or make it understand social cues, but by creating that standard, controllable interface to the real world, it feels like a really fundamental building block for making agents more reliable, more integrated, and actually scalable within businesses.
It definitely makes you pause and think about where this is headed. If you take the report's projection seriously, agents potentially handling month-long tasks by the end of the decade, and layer on those critical security concerns around tool access. What does this rapid standardization via things like MCP really mean for navigating that future? How do you balance accelerating the automation, which clearly has huge potential, with maintaining absolute control, security, and, maybe the hardest part, meaningful human oversight as these systems get more and more autonomous? What stands out to you as you think about all this? Thank you for joining us on this deep dive into AI agents and the Model Context Protocol.